Okay, so here is the review for chapter 3. It says to state the domain of the function in interval notation. First, we need to look at 1a, and we have f of x equals the square root of x over x minus 7. So what we need to do is we need to look at each one of these separately and figure out the domain restrictions and then put these together. So with the square root of x, we have to take the variable expression and set it to be greater than or equal to x. And then for x minus 7, we need to set that so that it's not equal to 0, and then solve that. So we're going to add the 7, and we know that x cannot equal 7. So individually, the domain for the square root of x is from 0 to infinity. And it looks like that. For x minus 7, it's saying that x cannot equal 7. Well, 7 is between 0 and positive infinity. So to put these together, what I need to do is go from 0 to 7, and then continue on from 7 to infinity. And so in this case, the fact that we have the union between the two interval notations, that's saying skip over the value of 7. Okay, so I'm going to move this over. Whoa, that wasn't supposed to happen. Okay, I guess I'll just, really? And what just happened there? What? Okay, there we go. So I'm going to erase this. And we know that our domain is from 0 to 7, skip over the 7, on to infinity. For part B, there's only one expression here. Because it's under a radical, we're going to set 3x plus 5 to be greater than or equal to 0. When we solve this, we get 3x has to be greater than or equal to negative 5, and then we divide by 3, and x has to be greater than or equal to negative 5/3. So in interval notation, we start at negative 5/3. It's a bracket, and we're going to continue on to infinity. Looking at the piecewise function for number 2, all we need to do is evaluate at f of negative 1 and f of positive 4. Well, at f of negative 1, x is equal to negative 1. We have these inequalities here to tell us which equation or expression to use. If negative 1 is less than 3, we're going to use the first expression. And so we take 3 times negative 1 squared plus negative 1, and that is our f of negative 1. So negative 1 squared is positive 1 times 3 is going to give us 3 plus a negative 1, which is going to give us an answer of 2. F of 4 is greater than 3, and so we're going to use the expression 5x. And so 5 times 4 is equal to 20. So for f of 4, we get 20. Now looking at number 3, it says graph the piecewise function. To be able to graph these, we need two tables. We're going to have f of x is equal to 2x plus 1, and we're using the values of x to be less than negative 1. So for the table, we need to actually include the negative 1 and then values less than negative 1, such as negative 2, negative 3, negative 4. The only thing that I need to consider is that we don't actually equal the negative 1, so we're going to start that graph with an open dot. When I plug in negative 1, I get 2 times negative 1 plus 1. So that's negative 2 plus 1, which is negative 1. When I plug in negative 2, I get negative 4 plus 1, which is negative 3. Plugging in negative 3, I get negative 6 plus 1, which is negative 5, and I'll get negative 7 for the negative 4. So when I go to graph this, I go to negative 1, and it's going to be an open dot. And then I go to negative 2, 3, and there's a solid dot, negative 3, 5, and negative 4, 7. I'm going to draw an arrow through those other dots. When I go to graph the second part of this piecewise function, I have to consider the values of x greater than or equal to negative 1. So in this table, when we include the negative 1, we actually include that in the graph, so it is a closed dot. Values greater than negative 1 are 0, 1, 2, and 3. When I plug in negative 1, that's negative 3 plus negative 1, which is negative 4. When I plug in 0, negative 3 plus 0 is negative 3. When I plug in 1, I get negative 2. When I plug in negative 2, I get negative 1. When I plug in 3, I get 0. So I'm going to go graph these points. So negative 1, negative 4 is going to be right here, and that's going to start with a solid dot. 0, negative 3, 1, negative 2, 2, negative 1, 3, 0, and I'm going to draw an arrow through all those other dots. And that is the graph of my piecewise function for number 3. Okay, looking at number 4, I have to graph the function. I'm sorry, we have a graph, and I need to find f of negative 2 and f of 1. Well, f of negative 2 means that x is equal to negative 2. What is y? So what we do is we go on the graph, we count over to negative 2, and we find the value of y on the graph when x is equal to negative 2. And that value is 1. So f of negative 2 is equal to 1. When I do f of 1, that is asking, or telling us that we have x equal to 1, and it's asking what is our y. So we go over to x equals 1, we find the value of y on the graph, and that's negative 2. So f of 1 is equal to negative 2. For number 7, I have to determine the average rate of change. Well, average rate of change is just like slope. And slope formula is y2 minus y1 over x2 minus x1. And if here I have a function in regards to t, so t is replacing our x. So if t is equal to 2, I'm going to say that's x1, and t equal 3 is x2. And so I'm going to find y1 by plugging in negative 2. So 2 times negative 2 squared minus 6 times negative 2. And I get negative 2 squared is 4 times 2 is 8, plus 12, because negative 2 times negative 6 is positive 12, and I get 20. So I get negative 2 comma 20 for my x1, y1. For x2, I plug in 3, and I find y2 by plugging in 3. So 2 times 3 squared minus 6 times 3. That's 3 squared is 9, times 2 is 18, minus 18, which equals 0. So I have another point, 3, 0, which is x2 and y2. and I do my slope formula. So y2 minus y1 is 0 minus 20, and x2 minus x1 is 3 minus negative 2. And 0 minus 20 is negative 20. 3 minus negative 2 would be plus 2, which is 5. And negative 20 over 5 is negative 4. So my average rate of change is negative 4. Number 9,